Hi, everyone. My name is Dan. I'm VP of Platform at AI21 Labs. Really excited to talk to you today on NLP Summit. The topic will be how to bootstrap a text-based AI application by leveraging huge language models using AI21 Labs technology and similar technology. So let's first briefly introduce AI21 Labs. We're a Tel Aviv-based startup. We are on a mission to transform the way people interact with written text, the way people read and write. Last year, we released our first product called Wordtune. It's a premium writing assistant that is available as a Chrome extension to help people write and express themselves better and more accurately. Its essential function is to help you rephrase a sentence and basically say what you mean using the best words. And recently, last month, we made our platform offering available. It's called AI21 Studio. It's a developer platform intended to allow practically anyone to build their own NLP applications, AI text-based applications. I'll quickly dive into Wordtune and AI21 Studio to sort of set the scene and explain our take on this emerging world of NLP and text generator-based applications. So here are a couple of snapshots of what Wordtune can do. You're welcome to install it and try it for yourself. I picked two sentences related to the conference, and the highlighted text are the sentences that I put into the system, and the drop-down menu is a menu of results that Wordtune lets me pick from. And these are alternative ways to say the same thing. And as you can see, the content gets, the semantics is preserved, but the phrasing is available in different variations. Some of them are relatively close to the original, and others are really different ways of saying the same thing. So that was our first product that we launched, and we're very proud of it. It has a growing user base and a lot of traction. And through that, we have learned a lot about what it takes to really build a real-world application based on the latest and greatest in NLP and text generation technology, which is one of the reasons we decided to make our own technology available through AI21 Studio. So what is AI21 Studio? It's a platform and an API to access our transformer language models. We have two language models available, J1 Jumbo and J1 Large. J1 Jumbo, J1 stands for Jurassic 1, is currently the largest English language model available to developers with 178 billion parameters. J1 Large is smaller, but also very capable and powerful with 7.5 billion parameters. They're available via API and also through a web interface. And as the benchmark results show on the table on the right-hand side, for things like zero-shot and few-shot language text solving, they are very capable and comparable or better than some of the contemporary models, specifically comparing Jurassic 1 Jumbo to GPT-3 Da Vinci. We see that it's more or less a tie. And comparing Jurassic 1 Large to the smaller GPT-3 Curie, we see that Jurassic 1 Large comes out slightly on top. Right, so this is kind of the story of AI21 in the last a couple of years, but no company is an island, and obviously all of this is happening on the background of the huge explosion and activity in NLP in general. So in case anyone fell asleep for the last few years, let's just quickly review the recent timeline. So in 2018 was really the Muppet age, with Elmo and Bert coming to the scene and demonstrating that large pre-trained language models can serve as very, very powerful backbones, meaning models that you then fine-tune for different tasks, either by adding a component and training, or just training the weights of the original model. And that was a very big step, because it allowed practitioners to take on specific tasks that would have required building a dedicated pipeline or architecture, and just treat them as fine-tuning on top of a pre-trained language model. And that has been deployed with a lot of success for a huge variety of natural language understanding tasks. And then we could say that 2019 was the year of the text generators, with GPT-2 first, and then Grover, and also others coming to the scene, and really demonstrating that these large language models can be used as very, very effective text generators, generating text at quality and coherence that was unimaginable with previous technology. And what GPT-2 also did is showed some first hints of zero-shot capabilities, where models trained in an unsupervised manner on just a corpus of web data are suddenly able to solve different NLP tasks zero shot, without being trained or without any additional tinkering. And then, of course, next year we had T5 and GPT-3 with kind of a new emerging idea that these large language models are useful as universal task solvers. So the T5 paper by Google sort of introduced the idea that more or less all useful tasks on text can be phrased as text to text, meaning the input is text and the output is text. And then OpenAI's GPT-3 showed for the first time really, really convincing results with zero and few shot task solving. And that really got people thinking about new ways to use these large language models in production for powering language applications. Now, of course, this sort of 2-minute description is glossing over a lot of details and omitting a lot of important work. The point here is to sort of show these three main ideas or trends that emerged. First, that large language models pre-trained on large-scale unsupervised data are effective backbones for fine-tuning. Then that they can be used as text generators. And finally, that there are coming close to being really universal task solvers for NLP. And actually, we've been playing this game as well at AI21 Labs and contributing our own work with SenseBERT, which was a proposal to modify the unsupervised pre-training of BERT to inject more semantics, with Chaim, which was a powerful text generator, and with Jurassic 1, our most recent edition. Right, so let's see where this evolution got us. This is what few-shot prompt engineering looks like with J1 Jumbo. The idea here is that you can take a simple NLP task, or seemingly simple, where the input is a sentence that contains some business jargon, and then the output needs to be a sentence that means the same thing but gets rid of the jargon and phrases things in more simple terms. Now, a few years back, solving something like this would have been a really daunting task. And with a powerful language model such as J1 Jumbo or GPT-3 Da Vinci, you can take that on in an afternoon and get to something that sort of works, which is what you see here. We have basically a text prompt that is fed into the model. It has 3 examples of the task correctly performed. So we have this repeating pattern of a sentence that contains jargon and then a simplified version. And then finally, we have our new sort of inference example where we feed in a fresh sentence, and we want to get the simplified version, which is the bold text in the end. And we see that the model is indeed capable of performing that. What happens here kind of under the hood is that the way we build the prompt exploits the language model's tendency to sort of latch on to patterns. And so if we establish this pattern of the word jargon followed by a sentence with jargon, and then the word simple followed by the same content but without the jargon, the model will tend to repeat that and sort of apply the same transformation to the new sentence. And we can walk through a few other examples. So here's summarizing restaurant reviews. In this case, we have one example above the separator with the 3 hashes, and we have a fresh example. So this is basically one-shot learning within the context of the prompt. We see that the model does a decent job at extracting these short phrases that summarize the longer restaurant review. And it also kind of preserves the style. So these language models can really pick up on very subtle clues in the text and kind of follow the pattern that you establish. Similarly, we can do things like generate product descriptions, like a one-liner or one-sentence product description from a list of features, or even translate code from one programming language to another. So in this case, we take Python code and convert it correctly to functioning JavaScript code. The reason J1 Jumbo was able to do that was because it was trained on code in addition to English language text. Right, so that's great. I guess the natural question is, are we done with all of this NLP business? Is a 180 billion parameter language model all you need? Basically, once you trained it, is it just a matter of tinkering with prompts in the process of prompt engineering, and you get mind-blowing results and you're good to go? So to some extent, yes, but to a larger extent, no. There's still a lot we can improve. One very important factor is cost. So to serve production traffic on a 180 billion parameter model is a very expensive endeavor. And even as costs decrease through competition, through the availability of GPUs, through architecture improvements, engineering improvements, and through research into making the few-shot and zero-shot capabilities accessible at smaller and smaller model sizes, even as that is occurring, it still seems that to be the case that you need a very large model to do this kind of prompt engineering work, and it's still expensive to serve that kind of model. So that's very important for obviously any practical use case. Another important limitation is context length. All of the in-context training happens in the context of the prompt of the model. So the prompt and the completion length are limited to around 2,000 words for GPT-3 and 2,500 words for J1. So that's a limit that is fine if your examples are short, but if your examples are long, you might be severely limited by that. So if your input is 600 words and your output is 200 words, you'll only be able to fit 2 or 3 examples within the prompt. And that means that you have a limited opportunity to improve by adding more examples. And that also means that if your product or application is based on is built on top of basically querying a large language model with an engineered prompt, all you have in that prompt is a few examples. So that's not really a way to build a data moat or any kind of proprietary data that helps you perform better or outperform the competition. The final issue is stability, to be more concrete, the fact that prompt engineering is still more art than science. So we write these instructions in the prompt and we add these examples, but we're not talking to a human being. We're guiding the function of a language model. So there are sometimes surprising failure cases, and it takes a while to figure out why some things work, why other things don't. There's a subtle science in there and a lot of art and rules of thumb. So that's in principle something that you would prefer to replace with a system that provides more stable and predictable results. And of course, there are also real reliability and safety concerns that arise in many use cases and are challenging for these applications based on large language models to solve. Right, so what we see as a way to address these limitations is to go back a little bit to fine-tuning. So fine-tuning doesn't suffer from these problems because in terms of cost, if you properly fine-tune a still admittedly not small at all, but much smaller language model, anywhere in the 100 million to 10 billion parameter range, you would get something very capable for pretty much any task we've seen. And these models can be deployed at a much lower cost compared to something like a 180 billion parameter model. So that's one advantage of fine-tuning. Another is that the context length issue is no longer a limitation, or it's a much smaller limitation. Each example can, in fact, occupy the entire context, and you're free to fine-tune on as many examples as you want. People fine-tune regularly on data sets with thousands and even millions of examples. And even more importantly, it is the case that you improve monotonically as you add more training examples and as you make your training data better, higher quality, more precise. So that also provides a way to address, at least in part, there are some very important discussions around this point, but at least to offer some way of addressing reliability and safety concerns through curating data that addresses them directly. But the obvious point here is that you need training data. And that really is the difference between the few-shot approach and the fine-tuning approach. So you basically have a choice between two alternatives. One here in blue is the few-shot approach. You need very little labeled data, just a few examples that can fit in the prompt, and you can improve very quickly by tinkering with the prompt. And you get to a certain performance ceiling, which is typically lower than what is attainable with fine-tuning, though that's not always the case. And anyway, it's hard to improve further. And of course, the advantage is that you get to decent or very good performance within a matter of hours of just tinkering with the prompt, picking the right examples, changing the format a little bit. Now, the alternative approach is fine-tuning, where you need to collect labeled data. And as anyone who has done that ever knows, it's a tedious process, and it's time-consuming. And typically, it could take weeks to collect a labeled data set of thousands or more examples that's high quality and representative and clean and suitable for fine-tuning a language model. So there's this gap here between what can be achieved with a huge language model by investing a few hours of tinkering with a prompt, and what can be achieved with fine-tuning by a tedious process of data collection and curation. And the payoff for fine-tuning would be that, again, you can fine-tune a smaller, more affordable, more stable model. So how do we propose to bridge this gap? And of course, similar things have been proposed in the past, but I think that in the context of the opportunities offered by modern-day large language model, this point is really important. What we propose is a very simple process. You build your prototype, your first version, your first iteration, by exploiting prompt engineering on a large language model like J1 Jumbo. And then you leverage that prototype to demonstrate your application, perform a few design iterations, take the first few design decisions, but also, more importantly, to start generating training data with the large model and prompt engineering. And as you collect that training data, you soon find that you have enough to fine-tune a custom model and deploy it. So let's take a look at a concrete example. We chose a very simple and well-known task of text classification on the AG News dataset. The goal here is to classify the topics of news articles. There are one of four possible topics for its four-way classification: world, sports, business, and science and technology. And the decision is made based on two inputs: the title of the article and its summary. It's a well-known task. It's been around for 6 years or so. And as you can see in the animation on the right, it's possible to get a pretty good solution for it with a Flushot prompt that we built on top of J1 Jumbo. And as you can see, for the last example, that is an article about plans for building a stadium, the model correctly outputs the right answer, which is sports, obviously. Right. So now let's play out this scenario with one of our three approaches. First, let's take a look at the blue line in the plot, which is what happens when you use Flushot prompt engineering with J1 Jumbo and collect a few manually labeled examples and put them in the prompt to get your Flushot performance. So as you can see, with zero shot, you get a slightly higher than 50% accuracy. And as you add more examples to the prompt, you improve in accuracy. But then at some point, you consumed the full length of the prompt, and you can't add more examples. So you're pretty much stuck. And then what you can do is obviously train a custom model based on fine-tuning on manually labeled examples. So this is the yellow line, which starts at around 20 examples and goes all the way to a few thousand. And as you can see, you can get pretty good performance. But of course, the price to pay is to collect the labeled examples, to label them manually, and to invest all that time. Now, the way to take a shortcut is, of course, to use the Flushot J1 Jumbo approach to auto-label more examples and then to train on them a J1 large custom model, which is what the green line represents. So the horizontal axis is still the number of manually labeled examples, but for the green line, we add to that the auto-labeled examples that we auto-labeled with J1 Jumbo, and we used a confidence criterion to select the labeled examples. So as you can see, with a very small number of labeled examples, you can basically reproduce the accuracy that you get with a custom model trained on thousands of manually labeled examples by leveraging your quote-unquote prototype of J1 Jumbo with a Flushot engineered prompt. So what's the takeaway from all this? So as we've seen, large language models such as Jurassic 1 and GPT-3 really open new opportunities in how quickly you can develop diverse applications by using prompt engineering. So the versatility and the time to prototype is really something unprecedented. And that's great. That means that what would have taken a big lab a few months of work is now possible to achieve by a single person working for a couple of afternoons. And that's great. The problem is that the solution you get is not very scalable. It's expensive and problematic to scale it up to production. So anything based on large LMs is bound to hit some sort of ceiling. That's why we propose kind of a two-step life cycle. You do the rapid prototyping using these large language models, and you do the prompt engineering that you need to get a functioning prototype. And then as your product grows and evolves and requirements grow and traffic grows, you will soon find yourself in need of a more affordable and stable solution. And that's when you leverage the prototype that you built with J1 Jumbo or GPT-3 DaVinci and collect the data set that you can train the custom model on. This is basically the offering that we're proposing with AI21 Studio. And we think this will really be the way to go for powering the next generation of amazing AI text-based applications. So thanks for your time, and thanks to NLP Summit for having us.